In this video, we are going to talk about the two types of friction, static friction and kinetic friction. In our previous video, we defined friction to be the contact force that resists sliding between surfaces. And there are two types of friction, static friction and kinetic friction. Static friction prevents an object from sliding across the surface. For instance, when you're trying to push a large table across the floor, the initial resisting is due to static friction, while kinetic friction is the friction when an object is sliding across the surface. So when you push a box across the floor, you will see the box slow down and stop, and that's due to kinetic friction. And one last thing you have to know about static and kinetic friction is that the coefficient of static friction is greater than or equal to the coefficient of kinetic friction. Now, if you're still confused, don't worry, because I'm going to diagram these two forces. So here we have two diagrams of the same box, but one is moving at a constant velocity and the other is at rest. And in the lecture, we said that the coefficient of the static friction is greater than or equal to the coefficient of the kinetic friction. Or in other words, we have to apply more force to get this stationary box accelerating than this already moving box. And I'll give you a moment to ponder why this is the case. Well, the answer has to do to the molecular interactions between the boxes and the surfaces. Let's look at it from a basic perspective. Both of these boxes experience the same type of chemical bonds between itself and the surface. And overcoming these bonds is essentially the force of friction. If we look from an atomic level, we will notice that no object truly has a smooth surface, and instead there are little bitty grooves. So when an object is at rest, or in this case our stationary box, these molecules will start to slide in or fit into these grooves. And when you apply force to these objects, essentially you have to overcome these already settled molecules by either breaking them off or the molecules have to be shifted up. Now, when looking at an object already in motion, you can think of the molecules of this box now having enough time to settle in these grooves. So instead, the molecules of the box is sliding on top of the surface. So in conclusion, we see that our stationary box has to overcome both the temporary bonds and these molecules that settled in these grooves in order for the object to accelerate, while the already moving box only has to overcome the temporary bonds. So this is a general idea of why the static friction has a greater coefficient than the kinetic friction. So in recap, friction is the contact force that resists sliding between surfaces. And the two types of frictions that we learned today are static friction, which is the friction that prevents an object from sliding along a surface, and kinetic friction, which is the friction when an object is already sliding along a surface. And we also learned that the coefficient of static friction is greater than or equal to the coefficient of kinetic friction. And one thing I forgot to mention in the lecture is that the coefficient of friction is usually between 0 and 1. And these numbers tell the roughness between the two surfaces, where 0 is slippery and 1 is very rough. And there are cases where the coefficient of friction is greater than 1, but we're not going to talk about that anytime soon. Thank you for watching this video and hope to see you next time.